Here I have our presentation on solar panels. Since we can't get out in the sun and play with real ones, what I did is I got on Google and found a simulation for a solar panel. And solar panels, unlike batteries, are current sources. Okay, they operate different than a battery, and there's ways that we could do measurements on these that would be impossible on a battery. So this here is a simulation of a solar panel, and we're going to hook these up in series and parallel and combinations and show you how they operate. Here we're showing the same solar panel, and what we're doing is two different measurements on it. So we do ISC, short circuit current measurement, where we're actually taking the ammeter and putting it right across the terminals. If we did with this as a battery, it'd blow out the meter. So since this is a current source, no problem. So with one panel, and assuming it's got the sun on it and everything else, it's going to come up with 1.45 amps. Another measurement that we do is VOC, the open circuit voltage measurement. Again, we're hooking a voltmeter, DMM, but we're using the voltage measurement side. So with this one, that's with sun with 27.492. So these are the two measurements that we do typically with a single solar panel. These are significantly higher than the little tiny ones we use, but this is fairly reasonable. Here we're hooking up our solar panels in series like we would with batteries, and they actually operate very similar to batteries when we do it this way. What happens here is when we series them, our voltage increases. Since we have two panels, it doubles. So our voltage at 27, maybe 0.5, is coming out to 54. That's reasonable. And when we put batteries in series, we usually maintain the same current, which is true of PV panels. So we're remaining at the original 1.45. Here we're showing PV panels in parallel. And typically in parallel, we increase the current. Since we have two panels, it's going to double the original 1.45, which is about 2.9, and our voltage remain the same. So parallel panels, current increases, voltage remains the same. Here we show another arrangement of solar panels. This one is in parallel. You notice that we have the positives connected together, and we have the negatives connected together. So these are all in parallel. And you notice that we have the one voltage, 27, and we have 6 panels at 1.45 amps, and we add out to the 6th one, we're going to come up with 8.73. So if we want to increase the current, we're going to go parallel. Here we have another configuration of our solar panels. We have 6 of them tied in series, so our current's going to remain the same as one panel, and then we're going to have 6 times the voltage. So series, we multiply the voltage times the number of panels. Here we've got 27.492 multiplied times 6, and we should come up with about 165 volts. Okay, so here's the last configuration I'm going to show. It's a series parallel, and we have 3 in series and another 3 in series. So that's going to be 3 times the voltage, 27.4 times 3 should come up to about 82.5 volts. And since we have these in series, these two links are in parallel, so we're going to double the current. So our 1.45 becomes 2.9, and this is the way that we increase both voltage and current, and this is the way home systems are typically done so that they could configure it for the inverter. And so if we want both, we do a series parallel system.